All right, we've been talking about proportional relationships, and today we're going to talk about something called rate of change. But first, a little factoid. Did you know that in elections in California, for every 15 people that can vote, 10 people do vote and 5 people don't vote? Did you realize that out of every 15 people that can vote, 5 out of those 15 just choose not to vote, not to exercise their right to vote, which is kind of like 1 out of every 3 people just decide, nah, I don't want to cast a vote. That's kind of crazy. But the reason I bring that up is because this is what's called a ratio. And you know what ratios are. A ratio is a way to compare two different numbers. So, in this case, we're comparing the number of people who can vote with the number of people who don't vote. 5 out of 15. Now, ratios are comparisons of two different numbers. So, you could be at a party with 30 people and maybe you look around and you notice that out of the 20 people at the party, 20 are girls and 10 are guys. So you would say that there's a 20 to 10 girl to guy ratio. You're comparing the number of girls with the number of guys. And you might realize that a 20 to 10 girl to guy ratio would be like a 2 to 1 ratio, right? And basically ratios are like fractions. You can reduce them, but unlike a fraction, we wouldn't simplify this and just put the number 2, right? Because 2 over 1 is 2. A ratio you would leave as a numerator and a denominator. You wouldn't get rid of the denominator because in a ratio, the whole point is to compare the two numbers together. So it's a 2 to 1 ratio, which you can also write this way or this way. You can write ratios with a fraction or using a colon, or you can just say the word or write the word 2, a 2 to 1 ratio. Okay, that should be review because I think we all know what ratios are. But just in case you don't, you could be comparing the number of girls to the number of guys with the 2 to 1 ratio, or you could be using a 2 to 1 ratio to say that there are 2 Starbucks at one street corner, or you could be using the 2 to 1 ratio to compare the number of peanut butter cups that you can buy to the number of dollars that you would spend on those peanut butter cups. And if you did something like this, what we would be saying is that you can buy 2 peanut butter cups for $1. And this kind of a ratio is called a rate. A rate is a ratio that compares different things. So instead of just comparing voters to voters or people at a party to other people at a party, now we're comparing peanut butter cups to dollars. We're comparing two different things. And that's what we call a rate. Okay? So, some other examples of rates would be if you are at a party and there was 20 people and you had 5 pizzas for 20 people. That's a rate. That's a pizza per person rate or a person per pizza rate because you're comparing two different things, pizzas and people. And you might go to the grocery store and buy some orange juice, and the rate that you pay for that orange juice is $4.99 for 96 ounces of orange juice. And since you're comparing money with ounces of orange juice, it's a rate because money and orange juice are two different things. And another example of a rate would be the rate at which you travel. Maybe you travel 120 miles in 2 hours, and since you're comparing miles and hours, which are two different things, that is considered a rate. So a rate just compares two different kinds of things. Now, a rate of change is the amount that one variable changes when another also changes. So if you're traveling 120 miles in 2 hours, time is changing and distance is changing. And this rate of change answers the question, how much is the distance changing as the time is changing? Or you could think of it this way, at what rate is the distance changing? It's changing at a rate of 120 miles per 2 hours. Because the distance changed 120 miles while the time changed 2 hours. And this ratio is what we would call a rate of change because it talks about the rate at which something is changing. Okay, so this past summer, I started collecting Pokemon cards. Yep, that's right. So I started off with 6 cards. In the first week, of collecting, I had 6 Pokemon cards, and then I got 6 more. So by week 2, I had 12 cards, and then I just kept on collecting myself some Pokemon cards, and I got 6 more. So by week 3, I had 18 Pokemon cards, and then I got 7 more. So by week 4, I had 25 cards. Okay, are these rates? Yeah, because I'm comparing time with number of cards. But what was the rate of change in this scenario? Well, hopefully you can see that for the first 3 weeks, the rate of change was 6 cards per week, because I got 6 cards in the first week, and I had 12 cards by the second week, and I had 18 cards by the third week, and since 6 over 1 equals 12 over 2, which also equals 18 over 3, we would say that this situation had a constant rate of change of 6 cards per week. I was gaining 6 cards per week. The number of cards I had was changing by 6 cards per week. But then something kind of funky happened, and then I got 7 cards in the 4th week, and that kind of threw off my rate of change. And now my rate of change wasn't a constant anymore, because that does not equal 6 over 1. So just to review, a ratio is a comparison of two different numbers, and it can be written as a fraction, or with a colon, or with the word to. A rate is a ratio that compares two different types of things, like dollars per ounce, or miles per hour, or peanut butter cups per dollar. And then a rate of change, which is the whole point of this video, is how much one variable changes as another changes, like how the amount of Pokemon cards changes over time, or how the distance that you travel in a car changes over time. So, let's see if you can put this into action. Could you write a ratio comparing the number of academic classes you have to the number of non-academic classes you have? Meaning, math, science, English, history kind of classes versus elective kind of classes. Could you make a ratio out of that? And then could you write that ratio in 3 different formats? I bet you could do that pretty easily. Now, how about a more challenging problem? If your starting salary at a new job is $40,000, nice, huh? And then after a year you get a raise to $46,000 a year. And then by your 5th year, you're making $64,000 a year. What is the rate of change of your salary? Try that and see what you come up with, and we will talk about that tomorrow. All right, that's rate of change. Hope you wrote some good notes, and if you have any questions, jot them down so that we can discuss them tomorrow.